Good afternoon, everyone. Today, inshallah, we will go to a new chapter. We will talk today about linear transformation. But before we go to linear transformation, this is the first lecture of this week. This is the fourth week. Time is flying, and I'm insisting on this. We are on the fourth week. Your exam will be after 2 weeks, so you should start working as much as possible. Please do go through the quizzes as much as possible and see the previous midterms. It's already available on Moodle. It's a disaster if you don't solve the previous midterms and the quizzes. It's really very important for you to see how the quiz is coming. As I told you, the model in SBE, it's really wonderful. You have everything on Moodle. You have previous exams, you have quizzes, you have videos, plus all the recorded lectures. You will find them on the YouTube. So I think you should be in a very good place. Okay, please do your quizzes, assignments, and don't forget plugs every week. For us, doing the assignments and the plugs is really not a very major issue, because usually on every Wednesday we get it written with all of us here in the campus, so it's manageable. But the quizzes, which is your responsibility, really very important. Although it's not necessary to show you something like this, but I've taken just a print screen from one of the Excel sheets that summarizes the grades. As you can see, those are some of you. See about quiz 1, quiz 2, it's zeros. Others, they already solved it more than once and they have 4 marks in it. Those are the grades of the assignments and the plugs for first assignment and second assignment. So please take it seriously. It is real, and the grades are gathered in this Excel sheet. Okay? And this Excel sheet is not relative to me, it's relative to Lisbon. So mainly start working as hard as possible, and I thought to share that with you in order to make you understand this is really important. As you can see, this is quiz 1, quiz 2, assignment 1, assignment 2, plugs, plug 1, plug 2, situation of the students, and so on. So it is already monitored. Done. Okay. Although this is not, I shouldn't do this with you, but I want you to remember once more the quizzes as I insisted on you. Remember to do quizzes as much as possible and test your knowledge repeatedly, never quit. Okay, he's asking you, this question is really very simple. He's asking you for, he's giving you an expression, and by the idea, the midterm questions are somewhat related and near this situations. It's gonna be seldom that you will find one of the questions of the quizzes or something that's gonna be repeated in the final exam or in the midterms. But just in case, it's gonna be, I'm sorry, but it's gonna be really very close to those problems. So he's giving you an expression for a matrix 2 by 2 and get its transpose, then do a multiplication, which is really very simple, between that matrix and the inverse of that one. We already know, Omar, how to get the inverse of this matrix as fast as possible. The determinant is equal to 2, so it is invertible. So I can do it by the empirical method. I make you, we have tried this several times. So you will get first the inverse of this matrix, do the multiplication, make a T or the transpose of this matrix, get the summation hazard, and then choose the right answer. I believe the right answer is gonna be this guy. Okay, for this question, also this is a very nice question. Any ideas? He's asking you, consider a system of linear equations. We already finished the systems of equations. Consider a system of linear equations, AX equal B. Being A an invertible matrix, please be careful. How many solutions does the system has? Okay, give me your ideas. Okay, once more, you have AX equal B, AX equal B. You know that A is invertible matrix. What does that mean? When A is invertible matrix in a system of equations, you know it will be between three classification. Either a unique solution, just only one solution, or infinitely many number of solutions, or no solution. So this system will contain one solution, or as many as the rank of the matrix A. طبعا ده افاتي.
ده مفيش حاجه
او zero او infinite. Which one? Which one is the
دكتور
correct
حاسس ان هو مش
answer?
مديني تفاصيل اكتر.
Yeah?
مش مديني تفاصيل.
You don't need to.
ازاي طب؟ يعني هو المفروض عشان اعرف المفروض يجيب لي يقول لي الرانك او يقول لي او يجيب لي حتى الماتريكس ذات نفسها وانا اعرف.
Just a sec. Didn't he give you the rank?
لا في.
If this is a matrix 3 by 3 and it is invertible, that means this matrix is invertible and the rank is equal to 3. If this system is 4 by 4, what's the meaning of invertible matrix? That the rank is equal to the augmented matrix, is equal to A, is equal to the number of unknowns. Am I right?
ماشي يبقى كده اللي هي solution.
معنى انها invertible يعني الرانك بيساوي النمبر اوف unknowns.
ماشي يبقى كده اسمه ايه ده؟ independent ليها حل واحد ما هو.
يبقى كده a consistent independent system.
تمام.
طيب when it's gonna have either no solution or infinitely many number of solutions. If A is not invertible, this matrix, you can't get the inverse of this matrix because it contains one of the rows equal to 0. Okay? So it needs a good understanding of all the propositions, of all the cases in order to answer this question. So it's really very simple. So it will lead to just only one solution. Okay? This is a very nice question and a tricky one. He's asking you, let A and B be n by n matrices.
ماشي.
Such that, remark, A times B to the power of 2 is equal to I. What do you understand from this? What does that mean? What does that mean? That A times B squared is equal to I. What does that mean? It has a meaning. You have to understand the meaning in order to understand, to give the questions or to know the right answer. Which of the following statements is not necessarily true? Is not necessarily true. It may be in special cases true, but it's not a necessary thing to be true. Okay? So one of them could be yes and could be no. Okay? So once more, I will get back to the main issue. Ya Hazim. A times B squared equal IN. What does that mean? It means that A and B squared are inverses from each other. Because if you have two matrices and you multiply A times B, let's say beta, where beta is equal to B squared. That's the main proposition. If you have A times B equal I, it means those matrices are inverses from each other. Am I right? So, if you have A times B squared equal IN, okay? Which means B squared is the inverse of A and the A is the inverse of B squared. Okay? He's asking you, is B invertible? Is this necessarily true? B must be invertible. Is B transpose is invertible? If B is invertible, then B transpose is going to be invertible. From where I get this point? From the propositions of the transpose. So see how strong this question is. It is linking the propositions of the inverse. Number one, you tell me you sleep in our lectures. How can you sleep in our lectures? So A, B squared is equal to I. That's a first proposition in the inversion. A is the inverse of B squared and B squared is the inverse of I. This is number one. This thing again, the relation between a matrix and its transpose. Because if the matrix is invertible, its transpose will be invertible. So already those two answers are linked to each other. And if A times B squared equal to I and both of them are invertibles, then this also will be invertible. A will be invertible. So it means this is the choice that you should choose. Because A plus B is maybe invertible in some cases or not a condition, not a necessary condition.
طب يا دكتور انا دلوقتي عندي سؤال.
Okay, just a second. Remark also that a times b squared to the power of -1 equal b squared to the power of -1 times a to the power of
-1.
So once I tell you that a and b are equal, a times b squared equal to in, they are invertible matrices. And also I have a times b squared equal b squared times a. So once you have a to the power of b squared to the power of -1, it's going to equal to b squared to the power of -1, a times a to the power of -1. In order a to be -1, since this is correct, so that one is correct. So a is invertible. Now you know that a invertible, and you know that b squared is invertible also, because it's equal to this value. At this point, from this relation, so this is necessarily true. This is necessarily true. That's necessarily true. A is invertible. So the only one, it may be invertible or it may not be invertible. It's gonna be the question or the answer number C. Of course, this type of questions needs a very good analysis and understanding for the propositions. How to approach the answer? Just step by step. Each word has a meaning. Why he gave me this relation? What to understand from this relation? This is the way how do you think and approach an answer for such questions. Okay? I don't want to lose more time, so please, if you have questions, I will delay it in this slide. And as I told you, you can solve it as many or as much trials as you can. This is a very good question too. He is asking you, Muhammad, starting from a matrix A with 3 rows. Now you know. This is a 3 by 3 matrix. Once more. Starting from a matrix which is called A, the matrix A. Has it with how many rows? 3 rows. The matrix A is again obtained, matrix A. I can get it. From where? Applying the following 2 elementary operations. Remark. By the given order. So apply the following elementary operations by the same order. This is process number 1, that's process number 2. Let E1 and E2 be the elementary matrices. So this is elementary matrix number 1, that's elementary matrix number 2. So the first elementary matrix, can you give it to me, please?
اللي هو عكس يعني خلى الرو الثالث بدل الرو الاول.
يعني ازاي بكتب الاليمنتري ماتريكس؟
هكتب اول حاجه كان
row 1 instead of row 3. So you mean this is gonna be 0 0 and 1.
ايوه بالظبط كده.
0 1 and 0 and that's 1 double 0. Am I right? You replaced the 2 rows in the 3 by 3.
ايوه.
From where did I know that's a 3 by 3? He mentioned A with 3 rows. Okay, the second operation with multiplying Omar, the first row by 7. So I will multiply, that's the second operation. Because the operations are going to be like this. This is number 1, that's number 2, that's number 3, and so on. So the second operation is multiplying 7, the first row in a 7. So
العكس بقى يا دكتور.
No. He multiplied the first row in a 7.
يعني انا ما بعملش اللي هي اول اليمنتري اللي انا طلعته ده وبشتغل عليه.
This is E1, that's E2.
ماشي تمام.
So once you try to arrange them, that's the first operation.
تمام.
That's the second operation.
تمام.
From the left. Okay, elementary matrices. Associate to the elementary operations 1 and 2. Okay, E1 and E2. Respectively. And the E is equal to E2 times E1. He shouldn't write this, but he gave it to you. The matrix E is necessarily equal to which matrix? So all I have to do is to multiply these 2 matrices together and choose the right.
بقى سؤال عادي خلاص.
Right? So just to go with step by step. And I believe the correct answer will be, I think, the first one. That's an application on Python. I believe Dr. Muhammad Saif was with you on the previous lecture. Please try to attend and to gather the questions related to Python to Dr. Muhammad. He can sit with you each 2 weeks or something. I will call him and let him sit with you if you have some problems. But you will have to do it on your own as much as possible. And still, if you have problems, just let me know and I will send it to them. Now I will go to our new chapter, which is the heading of this lecture. It's really very important. This chapter, it's called linear transformation. The concept is really very important. We will go through it step by step. Linear transformation, it's about transforming something from a dimension into another dimension, from a place to another place. Okay, it will start like this. I have Rn. What's Rn has it? Rn, it means a space, or it means when you have a vector in n variables. And remember, that was our introductory in the matrices and the vectors. We start first by defining a vector, then from the first lecture. And from a vector, we went through how to go through a matrix and link them together. The linear transformation starts from, we may have Rn, okay? And do we want to move to Rm? Okay, how can we move from Rn into Rm and vice versa?
How many
Okay.
plus 1 or minus 1?
I will have, it's like x and moving to a times x. That's the transform. That's the function responsible about moving the stuff from the first dimension to from the n dimension to the m dimension. It's the transformation T. Okay, the starting domain, or the starting set, it's Rn, it's called the domain. The ending, it's gonna be called the codomain. So at this time, now we can define that any transformation, it's a T of x, where x belongs to Rn, and the result will be A times x. That's what explained in front of you. For all these x values, they are vectors in n. And the result that you will have, it will move you to m. I usually like to write the transform such that moving the stuff from Rn into Rm. So I can successfully move stuff from 2 dimension into 3 dimension, or move stuff from 3 dimension into 4 dimension, and so on. So I can move vectors from the 2 dimension into 3 dimension, or from 1 dimension into 2 dimension, and so on. Or from 3 dimension to another 3 dimension, as you will see. So that's the start of a transform. The transform means I'm transforming x, which is in the main domain, to be a times x, which is a new values in the codomain. Okay? Okay. Once more, in the coming slide, you will see this transformation also explained. Once more, this is x, which is a domain in Rn. I will use the linear transformation, or this transformation, to move it to a times x in Rm, which is the codomain. In this slides, a map T, which moves the stuff from Rn into Rm. It's called a linear transformation. Okay, we will know what's the condition of linear transformation down the road, but it's called a linear transformation. If there is an m by n matrix, that's the matrix of transform, such that T is defined by the linear transformation will plan or map the elements x in Rm into Rm by using this small matrix, which is the matrix of your transformation. Okay, for all x, it belongs to Rn. And after transformation, the results will be in Rn. Okay, in that case, the matrix AT is a unique, and it is called the transformation matrix, as I told you. Okay, let's look to this problem. This problem is really very important. Step by step. He's asking you, consider, or he's telling you, consider the linear transformation that moves stuff from where to where? that will move elements from R2 and they map them. You will have their images, but in what? In R3. With transformation matrix, I've gave you the transformation matrix, which is 3 by 2, as you can see. Okay, what is the image of the vector U? What do you understand from this statement? That I'm giving you a vector. How many components do you have? So it is in the main domain. Okay? I need the image. So I need what's gonna be after the transform. It's really very simple. So now I have T transforming the vector U or the vector U. Let me stay with U. That's the vector U, which is equal 3 and 1. And the result will be AT times X. This is the linear transform that I'm going to use. So simply I can say, AT times U. So simply the matrix of the transform is معايا يا عمر -1 2 1 2 يا حازم 0 and 5. What's the part that you are going to move? This vector. Okay, so multiplying by this vector. This matrix is 3 by 2, and the vector consists of 2 by 1 because it contains two components. 3 and 1. So the result will be, let's see. Once you multiply these two matrices in each other, the result will be 3 by 1. So actually, I am moving from R2 into R what? 3. Let's do it. Multiply the row by the column. So it's going to be -3 plus 2. So -3 plus 2 is going to lead to -1. Multiply the second row by the first column. So it's going to be 3 plus 2. So it's going to map into a 5. Multiplying the third row by this value. So it's going to be mapped into 5 also. So it's 1 times 3 plus 2. So it's going to be 5. 0 times 3 is 0. 5 times 1 is 5. -3 plus 2. So it's a -1. As you can see, this is the image. So in the M domain, you have R2. How many components?
2.
And the image after transformation, ya Hazim, how many outputs?
3.
3 of them. This is how to move from R2 into R3 using this transformation or this matrix of transform.
دكتور كان عندي سؤال. هو انا ايه اللي خلاني دلوقتي اللي اكتب ال 3 1 كفيكتور يعني كاتنين روز بدل ما اكتبه 2 كولومز؟
ازاي تكتبه 2 كولوم؟ هو الفيكتور بتاعي ده
دايما بكتبه على الروز يعني؟
بكتبه دايما في شكل column. I can give it as a row, but you understand this is the first component, second component.
تمام.
اوكي؟
يعني انا بعملها على حسب المساله، سواء هعمله بالعرض او بالطول.
ايوه.
تمام.
على حسب الاستخدام بتاعك. ماشي؟ على حسب انت تستخدمه.
على حسب الماتريكس اللي قبليه عشان يبقى مظبوط عليها.
ايوه. بص بقى، ده الجنرال ترانسفورم، ده ترانسفورم. تي اوف اكس، شوف الحركه دي خطيره جدا. التي اوف اكس اتس ايكوال تو ذا A matrix times x. هذا الاي ماتريكس which is the transformation matrix، وده اكس اللي هو الفيكتور اللي جوه. انا عايز بس تخلي بالك، تحس قوي باللي انا بقوله ده. الترانسفورم ده او الفانكشن دي بتموف الام اللي هو اكس وتطلع ايمج، الايمج هتطلع شكلها عامل ازاي؟ ايه في اكس. اوكي؟ طيب تعالى نعمل الكلام ده. يبقى اذا T of U it's equal to A transform times U. So multiply these two matrices together. Once you multiply them together, that's gonna be the outcome. So now I have a link. I have 3 and 1, and after transforming, it will be transformed into -1, 5, and 5. Are you with me? Okay, perfect. Now let's go to the second step. What are the objects or what are the main vectors which its image through T, which means the image through T is just only 3, 1, and 5. How to get this? In the first part, I've given you the vector in 2 dimensions and I've requested the vector in the 3 dimension. Now I'm doing the reverse. I'm giving you the outcome vector which is in 3 dimensions. And I'm asking you about the components in the 2 dimension. How to do it?
Inverse.
It's very, very simple. I can do the inverse, but the inverse is not available for each matrix. But I can do it by another way. I can say that we have T, which is equal to A times
X.
U or X or whatever. Now I know that the image of this vector is given. So A times U is given, which is 3, 1, 5. What is missing is this vector. So simply I can write the A matrix, which is the matrix of the transformation, which is -1, 2, 1, 2, 0, and 5. Then I have a missing values, which are x1 and x2. Those are the components of the V vector. And after you make your multiplication, the result, or after transform, the result that you will have is 3, 1, and 5. I need to know the object. I need to know the elements in the main plan. Okay? So it's simply like solving a system of equations. Actually, it's row 2, 3. Okay, so it's a 3 equations in 2 unknowns. Okay, I can solve it really very quickly. I can do the augmented matrix. You are a master in this, I hope so. So I will write the first matrix, which is -1, 2, 3, and the second row is 1, 2, and 1. The third row is 0, 5, and 5. So I've did the first row, second row, and third row. Now I need to solve this system, Mr. Hazan. You tell me that's the only region that I sleep in. I wonder, how can you sleep with this? Okay, try to solve. Let's solve this question. ها؟
طب يا دكتور هو انا ليه ما اختارش على طول من الاجابات؟
أنهي إجابات؟
يعني انا معايا الفورميول، معايا الايكويشن، وهيبقى مديني مالتيبل تشويس. انا ليه ما احطهمش كل واحده مكان الاكس 1 والاكس 2 والاكس 3 واجرب؟
ما ينفعش ازاي تعمل ازاي؟ كان اكس 1 واكس 2. ده افتر ترانسفورم.
ايوه انا فاهم.
عشان احنا دلوقتي قلنا ان الترانسفورم بتاعي اهو ده R3 وده R2.
ايوه يا دكتور.
انت عندك الفاليوز هنا، انا عايز ده.
انا فاهم. مش هو حضرتك بنتكلم احنا عايزين نجيب الاكس 1 والاكس 2 والاكس 3.
The ideal solution.
ماشي.
I'm not looking for x1, x2 and x3. I'm looking for x1 and x2 بس.
ايوه
This is the vector
ايوه
in
انا بتكلم
R2.
في نفس الفكره. ايوه بتكلم.
خليها كده بالطريقه.
انا اقصد اللي هو يبقى مديني مالتيبل
Don't
تشويس.
think about other solutions. Do first the master way, then we will think about if there is any other solutions to think about. So the main way is to solve this system of equations. Okay, let's solve this system of equations. Mr. Hazan, how to solve this system of equations? Quickly, please. I will need to be sure that the pivot of the first row is equal to +1. How to do it? I can do it in plenty of ways. Just replacing these 2 lines, or these 2 rows, or multiply the first row in negative. Ya Omar. So I can simply multiply the first row in -1. So it's gonna be 1, -2, and -3. Then I will use this row to force the remaining elements to be zeros. So I will multiply -1 plus 1, the result is going to be 0. 2 plus 2, it's going to be 4. 3, 1, it's going to be 4. For the last row, it's already zeros, 0, 5, and 5. I will continue with the pivot of the second row. The pivot of the second row should equal to +1. So I will divide on 4. So the matrix simply will be dividing on 4, it's going to be a 0, 1, and 1. Then I will use this pivot, Ya Omar, to force -2 and the 5 to be zeros. So I will multiply in 2 and add to the first row. So multiplying into 2 times 0 plus 1, this is going to be 1. 2 plus -2 is 0. 2 times 1, 2, -3 is going to be -1. I will do it once more, Ya Hazan. To be sure that this 5 is going to be moved to 0. I will multiply -5 and add on the last row. So it's going to be zeros, as you can see. Now I can find the solution very quickly. Now the solution is x1 is equal to -1. And x2 is equal to +1. So you don't have to exert a lot of effort. At the time being, now I know that the main vector, which is negative 1 and 1, using this transformation matrix, معايا محمد, it will be transformed to a new vector, which is 3, 1, and 5. Now I know how the vector, or what's the corresponding values for this image. So this is after transformation, this is the values before transformation, which is negative 1 and 1. Okay? This is very, very important. Once more, let's go through it together. Okay. This is the linear transformation. So it's T of x is equal to V. So A matrix times x equal to V. So simply, it is like solving a system of equations. It's solving a system of equations. This is the system of equations that I want to solve. So I'm seeking x1 and x2. So it's really very simple. This is the augmented matrix. Try to play a little with the augmented matrix as I did. So you will get your solution. x1 equal negative 1, x2 equal 2, positive 2. Those are the two values. The last equation, of course, it's a redundant equation. 0 is equal to 0. So only the vector negative 1 and positive 1 has an image equal to V, which is given to you by 315. Now the last part here, what is the general expression that defines T? How to get the general expression, okay, written, that defines this transformation. So if I told you that this transform, which is T, of any vector x, it can be explained as the following. X, it contains x1 and x2. So this is x1 and that's x2. The result will be, I will use this transformation matrix, which is negative 1, 2, 1, 2, 0, and 5, and multiply it by the two components of every vector in the main domain and get the image in the codomain. Start to multiply. So the first component will be negative x1 plus 2 over x2. The second component will be x1 plus 2 over x2. And the last component will be 5 over x2. That's the general expression. So any vector in x1 and x2, I can get its image حازم. ازاي? I will substitute by these two values in these three components, and I will get the image. This is what's meant by a general expression. Here's the T. Here's how you multiply the transformation matrix times x1 and x2, which is in R2, and that's what you got in R3. Okay? This is very, very important. As you can see, those are negative x1 plus 2, x2, blah, blah, blah. If you remark, this question is really very easy. It showed you how we move stuff, معايا عمر, from R2 into R3. So each two components in R2 can be used to develop a new component, but in R3, using this general expression. You will feel it more with more problems. Okay, I need to define what's a kernel, and this is very, very important. The kernel of any transform, first of all, T is such that, T is a transform, okay? Such that. Transform ده بيعمل ايه؟ بيمove stuff from Rn and map them into Rm. It will take main source in Rn and it will have an images or make an images but in Rm. This transform. Okay, the kernel of T denoted by ker T. So once you see kernel of T, it means that, or the definition, it is the set of all vectors. It is the set of all vectors, such that the transform on those vectors will be mapped in 0. I wish you understand what I'm saying. Okay, those vectors are a subset from Rn. The kernel is the subset of all vectors that's already contained in Rn. Once you do the transformation, they will be mapped in zeros. يعني انا بدور على الفيكتورز اللي موجودين في المين دومين، اللي لو انا استخدمت اللينير ترانسفورميشن هينقلهم فين؟ في زيرو. يروحوا 0 0 0. لو انا في R2 Rn، في R2 رايح R3، يبقى بدور على مجموعه الفيكتورز اللي فين؟ اللي في R2، اللي لما اسلط عليهم اللينير ترانسفورميشن يروحوا في الماتريكس 0 0 0. لو انا from R2 into R4 يبقى انا بدور على مجموعه الفيكتورز اللي موجوده في R2، اللي لما تيجي تضربهم في الماتريكس يروحوا رايحين 0 0 0 0. ده اسمه كيرنل. واضحه؟ يبقى تاني خلي بالك مهم قوي. The kernel of a transform، kernel بتاع ترانسفورم، اوكي؟ denoted by curve of T. الكيرف بتاع T، ايه الكيرف بتاع T ده؟ هو عباره عن مجموعه الفيكتورز اللي فين؟ في المين دومين، اللي لما تسلط عليهم الترانسفورم يروحوا فين؟ زيروز. ده معنى كلمه كيرنل. كلامي واضح؟ طبعا خلي بالك ان الست دي سبست من مين؟ اشمعنى Rn؟ لان ده المين دومين. ما انا بدور على الفيكتورز اللي في المين دومين، اللي لما اجي اعمل لهم صور ينزل الصور في الاصفار. ده اللي اسمه الكيرنل. ماشي الحال؟ طيب مين هو الكودومين او الرينج؟ الرينج it is the set of all vectors after the transform. يعني بعد ما امسك كل الفيكتورز اللي Rn وانقلهم، الست بقى بتاع اللي بيطلع، يبقى اذا كل الست of all vectors range of the transform it is T of x such that x belongs to Rn. كل الفيكتورز اللي تدخل في Rn وتطلع الايمجز بتاعتهم belongs to مين؟ subset from مين؟ from Rn. يبقى الرينج بيتكلم على الكودومين، لكن الكيرنل بيتكلم على الفيكتورز اللي في المين دومين، اللي لما انت تعمل لهم ترانسفورم يتنقلوا في مين؟ في الكودومين، في الزيرو بتاع الكودومين. معايا يا شباب؟ عايدها تاني؟ Are you sure؟ اوكي، هناخد عليهم بروبلمز بس next time. Okay, let's talk. See this, that's another way or another question which is really very good. First of all, how can we find the transformation matrix? How can we find the transformation matrix? Okay, of the linear transform. Linear transform ده بيعمل ايه؟